Okay. Assalamualaikum everyone. We have to continue with the chemistry. We can do bio next week. Basically, I'm continuing with the chemistry. We had discussed enthalpy changes yesterday. So let's continue the chapter. We can cover different types of enthalpy change today. Wait. Okay. So let's start. Okay, we have discussed that there are two types of process, endothermic or exothermic. There is little difference between endothermic and exothermic. I'm not talking about reactions right now. I'm talking about a process. Endothermic process means heat will be absorbed. Exothermic process means heat will be evolved. Let me check one thing here. Okay. Yes. So there are two types of process, endothermic and exothermic. Endothermic means heat will be absorbed. That's what we discussed yesterday. Exothermic, heat will be released. Okay. There is one more thing which you should remember, and that is bond breaking. Bond breaking is endothermic. When you are breaking the bond, so the reaction is called endothermic. And bond making is exothermic. We had discussed one more thing yesterday, and that is enthalpy change, delta H. This is enthalpy change. This is I told you this is energy change actually. I mean, what kind of energy change will be there? Um, that is another discussion. We have to discuss. We have to do some numerical work that how to find energy change. But let me tell you, if the overall reaction is endothermic, if the overall reaction is endothermic, so the value of delta H will be positive. I'm talking about overall reaction. Otherwise, in every reaction, there is a portion which is endothermic and there is a portion which is exothermic. I'll revise that thing again. See, so when the overall reaction is endothermic, means the value of delta H, the value of enthalpy change, the value of energy change is positive. And when the overall reaction is exothermic, means we discussed one statement yesterday, means when products are releasing their own energy in the environment, the reaction is exothermic and the value of delta H will be negative. The value of energy change will be negative. Okay. And this is all about overall reaction. When the overall reaction is exothermic and when the overall reaction is endothermic, then we can find the energy change. Now, otherwise, let me tell you one thing. For example, AB plus AB plus CD, and together they are giving you AD plus BC. See, so this is the reactant side. At reactant side, there should be bond breaking. Definitely, A should be separated from B. C should be separated from D. Then A will attack on D and it will make AD. Then B will join with the C and it will make BC. So you can see at the reactant side there is bond breaking, and bond breaking is endothermic. At the product side there is bond making, which is exothermic. So reactants are doing something like endothermic process, means they are absorbing energy to give you the bond. They are absorbing energy to break their bond, and the products are releasing energy so that they can form new bond, they can make bond. But we have to check that how much energy is being absorbed and how much energy is being released. The difference will tell you about the overall reaction. I mean, if the difference is positive, overall reaction is endothermic. The difference is negative, the overall reaction is exothermic. Wait, we have to do energy diagrams today. So let's start from exothermic. We have already done exothermic in detail. Exothermic reaction means the overall reaction is exothermic. Okay, see. Let's, okay, we can pick an example. Magnesium plus H2SO4. Magnesium is a metal, reactive metal. H2SO4 is a stronger acid. when when you are reacting magnesium with H2SO4, you know very well the reaction will be little vigorous, or you can say the reaction will be I mean, the reaction will not be explosive because we are using magnesium, not sodium and potassium, but the reaction will be vigorous. And you know, vigorous reactions are exothermic, means heat energy will be released. The reaction between metal and acid will be exothermic all the time. The combustion reaction will be exothermic all the time. Combustion reaction, energy is, I mean, we have glucose inside the body. That there is a combustion of glucose inside the body, and then you get energy. So energy is being released by the combustion of glucose. So energy is being released exothermic. So all the combustion reactions are exothermic, and all the reactions between metal and acid are exothermic. You know, neutralization reactions are mostly exothermic, but we do have some neutralization reactions which are not exothermic. But again, 90% neutralization reactions are exothermic. Reason? Involvement of acid. You know, acid is something which can give you heat energy. It will give you something like exothermic. So whenever there is involvement of acid, so there is a possibility that your given reaction could be exothermic. So the reaction between metal and acid will be exothermic all the time. Okay, let's make the product. Um, I guess you all know that whenever metal react with the acid, so it give you salt and hydrogen gas. There will be hydrogen gas, which is telling you that the reaction is vigorous. You know, hydrogen gas is explosive in nature. Okay, and you will get metallic salt. Sulfate group is there, so you will get MgSO4. Magnesium has +2 valency, SO4 has -2 valency, both will cancel, so the formula is simple, MgSO4. Okay, so this is the reaction, and this is a reaction between acid and the metal. So the reaction is exothermic. Keep in mind, you don't have to learn the values of energy change. That thing will be given all the time. You don't have to learn that how much energy will be released during this reaction. You don't have to learn that stuff. But let me tell you, the value of delta H will be negative here. What does it mean? It means that the reaction is exothermic. Now let me tell you one thing again, which we have already discussed yesterday. This is the reactant side, this green portion. This is the reactant side. Okay, there will be bond breaking. Definitely there should be bond breaking. H2SO4 should give you sulfate group, so there should be bond breaking. So you can see at the reactant side, the reactants are breaking their bond by absorbing energy, means they are absorbing energy. They are doing something like endothermic, because there is bond breaking. At the product side, there is new bond formation. Magnesium is making bond with the sulfate group. This is bond formation. Means when you make new bond, the energy usually release into the environment. So there will be something like exothermic reaction because there is bond making stuff. So you can see both the process in this reaction: the endothermic process at the reactant side, the exothermic process at the product side. But I'm saying that overall reaction is exothermic. Why? Because let's suppose that reactants are absorbing 100 joules of energy. I mean, they have to absorb energy so that they could be energetic. When they get energy, they will start vibrating or moving. You can say due to vibration or movement, their bond will become weak, and this will be very easy for them to break their bond. So they are absorbing energy. Okay. At the product side, new bond there is new bond formation. At the product side, you can see magnesium is making bond with the sulfate group. So right now, the bonds have been broken. So the particles are much energetic right now. They are moving. When the particles are moving, for example, there is magnesium and there is sulfate group. They are more energetic right now. So when magnesium and sulfate both are coming close together, so they are not relaxed right now. They are continuously moving. They are energetic right now. So magnesium is unable to give its electron to the sulfate group. So they have to release their energy. Which energy? The energy which they have gained to break the bond. I mean, they have gained 100 joules of energy. They have to release that 100 joules of energy back to the surrounding, because they have absorbed energy from the surrounding now. So they have to release that energy back to your surrounding. And then when they have released their energy, now they have less energy. So they will be less energetic. They can be relaxed now. And it will be very easy for the magnesium to lose its electron. And it would be very easy for the sulfate group to pick the electron of the magnesium to make magnesium sulfate. But what happened during this reaction? The reactants are absorbing 100 joules of energy, but they are not giving you back that 100 joules. They are giving you 120 joules of energy. This is just for example. There could be different type of energy. There could be different type of enthalpy. Okay, so see, the reactants were absorbing 100 joules of energy when they were breaking the bond. And when there is bond formation at the product side, so the energy which is being released back to the surrounding, that is 120 joules. We had given 100 joules only, and we are receiving 120 joules. 20 joules extra. 20 joules extra means the products are releasing extra energy to the environment. They have to release energy. They have to go through with the exothermic process. They have to release energy so that they could be less energetic, so that they could make new bonds. But they are releasing some extra. They have to release the same energy which they have absorbed during the bond breaking, but they are releasing extra energy. So the reaction is exothermic. Or how can you calculate? Because we have discussed that delta H should be negative. How can you calculate that delta H? Means the energy change. I told you one formula: reactant minus product. The actual formula is energy which is absorbed during the bond breaking minus the energy which is released during the bond formation. It's up to you. You can write this formula or go with this one: reactant minus product, because at the reactant side there is energy which is being absorbed. At the product side, the energy is being released right now. So you can write reactant minus product. What was the energy of the reactant? 100. The products are releasing extra energy, 120. The answer will be minus 20. This is the value of delta H, which is negative, which is telling you that the reaction is exothermic. Okay. Now, what is energy level diagram? Okay, let's draw. Oh, let me tell you one more thing here. We had discussed this reaction, which is magnesium plus, wait, let me write like this: magnesium plus H2SO4. Together, they are giving you MgSO4 plus H2. Okay, definitely we are doing this reaction in a container, you can say, or you can say if there is a system in which we are doing this reaction, or you can suppose a container. Okay, around this magnesium, or around this acid, and around this magnesium sulfate and hydrogen, there is something which is called surrounding. Surrounding could be beaker. Oh yes, you can say the surrounding could be beaker. Beaker is the surrounding. Inside the beaker there is a system in which they are performing a reaction, so the beaker is acting as a surrounding. Okay, and we just discussed now that the reaction is exothermic. Okay, now listen, because we have to discuss the energy of the products, and we also have to discuss about the surrounding temperature. For example, right now, I mean, the reaction is not started yet. For example, right now, the temperature of the surrounding, means the temperature of the beaker, is, for example, 40 degrees Celsius. Or let's make it a little less, 25 degrees Celsius. Okay, this is the initial temperature of your beaker, or this is the initial temperature of your container in which you are in which you are going to do some reaction. Beaker or this container is a surrounding. Okay, so right now it is having 25 degrees Celsius of the temperature, and we just discussed that when magnesium will react with the sulfuric acid, there will be bond breaking, means there will be endothermic reaction, means the energy will be absorbed. Where, I mean, from where they are getting energy? From the surrounding. They will get energy from the surrounding, and surrounding is the beaker, means they are absorbing energy from the surrounding. So the temperature of the beaker will drop because they are absorbing energy. So beaker will cool down. When you start the reaction, beaker will cool down. When magnesium is reacting with the sulfuric acid, at the reactant side, you can say the beaker will cool down because the energy is being absorbed from the surrounding, which is a beaker or which is a container. So for example, the temperature will drop. It will be, for example, 20 degrees Celsius right now, because magnesium and sulfuric acid, these two reactants have absorbed energy from the surrounding, so the temperature will drop. Okay. When there is bond formation at the product side, so they will be releasing their energy. And we just discussed that the energy which is being absorbed, so during the bond breaking, so product should release the same energy back to the surrounding. So the initial temperature was 25 degrees Celsius, and when there was bond breaking at the reactant side, so the reactants were absorbing energy, so the temperature of the beaker will drop to 20 degrees Celsius. But when there is product formation, so the temperature of the beaker will be 25 degrees Celsius again, because the product will be releasing the same energy. When they are making new bond, they are releasing the same energy which was being absorbed at that time when there was bond breaking something. So the temperature of the beaker will be 25 degrees Celsius again. So we can say the reaction is neither exothermic nor endothermic. But in this case, what happened? The temperature of the beaker will be more than the initial temperature. It could be 30 degrees Celsius. The temperature of the beaker will increase. The initial temperature of the beaker was 25 degrees Celsius, and the final temperature is 30 degrees Celsius. It means the products are releasing their energy to the surrounding. But I have told you one more thing. When you start the reaction, there is bond breaking, no? So the particles will absorb energy. So first of all, the temperature of the beaker will drop, and then product will add that energy again to the beaker, again to the surrounding. So the temperature will raise again. If the final temperature is greater than the initial temperature, the final temperature of surrounding, not the product. If the final temperature of the surrounding is greater as compared to the initial temperature, it means product have released some extra energy. Products have added some extra energy to the surrounding. That's why the surrounding temperature has been increased during exothermic reaction. We are not discussing endothermic right now. This is all exothermic discussion, you can say. Okay, so the temperature of the surrounding will increase, but what about the product? What about the product? Products are releasing their internal energy to the surrounding. The products are releasing their internal energy because they have, for example, they have absorbed 70 joules of energy when there was something like bond breaking. So they should release 70 joules of energy back to the surrounding, but they are releasing 100 joules, means 30 joules extra, means that extra 30 joules is the internal energy of the product. What is internal energy? This is your past paper question. What is internal energy? That is not the heat energy only. Internal energy is the sum of all the energies present in something. For example, my internal, if someone asks me about my internal energy, that is the sum of kinetic energy, heat energy, potential energy, chemical energy present in my body. That is the internal energy. So the products are releasing their internal energy. So when the reaction is exothermic, that's okay, that the delta H, the value of delta H will be negative, heat will be released, but you should know about the surrounding and the product. When the reaction is exothermic, so the temperature of the surrounding will increase as compared to initial one. The final temperature of the surrounding will increase because products are releasing their own energy. They are adding heat into the surrounding, and the energy of the reactant will decrease. Oh, sorry, the energy of the product will decrease. Products will be less energetic as compared to reactants because they are releasing their internal energy to the surrounding. So the energy of the product will be less in case of exothermic reaction. and the temperature of the surrounding will increase when you are doing something like exothermic reaction. That's what happened when you are doing something combustion reaction. What is combustion reaction? The burning reaction. No? Whenever you burn coal, a carbon for the barbecue, that is combustion reaction. The carbon is being burned in the presence of oxygen, that is giving you oxygen gas and a lot of heat energy. So surrounding temperature increases. Forget about the coal. We cannot discuss about the coal here. That what is the energy of the coal? The energy of the coal. Oh yes, the energy of the coal will decrease because the reaction is exothermic. So when you're burning the coal is adding heat energy into the surrounding. So the surrounding temperature is increased. And I use one more statement here, na, that the energy of the product will decrease. I didn't say that the temperature of the product will be decreased. I didn't use the word temperature for the product. I said the temperature of the surrounding will increase. The energy of the product will decrease because products are releasing their internal energy to the surrounding. Same cases here with the coal. Coal is adding its internal energy to the surrounding. So the energy of the coal will decrease. What is coal? Chemical energy. When you are burning the coal is being consumed. So the energy is decreased. Coal, I mean, when you have burned the coal, so whatever is the product that is less energetic, that has less chemical energy. This is exothermic reaction. This is the detail of exothermic reaction. Anyone is having any question right now? Then I can move to energy level diagram. Yes, Sabur, any confusion?
No, miss.
Yes, Ifa. Any confusion?
No, miss, it's clear.
Okay. Yes, Hera and Edina and Heza, do
No,
you have any
it's clear.
confusion? Okay.
No, no
Hmm.
confusion.
All right. Let's move to energy level diagram. Okay, let's continue with exothermic now because we are doing exothermic. Let me check. Let me remove the board now. Okay. So you can consider any reaction. You can consider the same reaction we just discussed, or you can pick some other reaction like combustion reaction. Yes, all the combustion reactions are exothermic. Na? So let's pick some combustion reaction. The commonest one is the combustion of methane, CH4, O2. And whenever any hydrocarbon, any organic compound, that hydrocarbon or organic compound could be any hydrocarbon, any longest chain of hydrocarbon, or that there could be any organic compound, alcohol, ketone, or anything. Whenever you react them with oxygen gas, so this is called combustion reaction. You will get only two products, carbon dioxide and water, and large amount of energy. And that will be negative here because all the combustion reactions are exothermic. What is energy level diagram? I told you one thing here about the energy of the product. Again, I didn't use the word temperature for the product. We are not using word temperature for the product. I said energy of the product will be less because the reaction is exothermic, because they have released their own energy into the environment. Okay, see. This is called graphical representation, you can say. Okay. And on x-axis, we have reaction pathway. I mean, the direction of the reaction. The reaction is going in this direction. Simple. On y-axis, we have energy. Or you can say we have enthalpy. We are using word enthalpy instead of energy. Okay. We just discussed, because we are discussing exothermic, so we just discussed that when the reaction is exothermic, so the product energy will be less. The energy of the product will decrease. Reason? Because the products are releasing their own energy, their internal energy from to the environment, to the surrounding. It means the energy of the product will decrease. It means we are comparing the energy of the product with something. Definitely. We are comparing the energy of the product with the reactants. I mean, when the reaction is exothermic, so reactants are having more energy, but the products are having less energy because they have released their internal energy. So reactants have more energy, the products have less energy. Okay, and this is called energy change. Okay, um, here, oh wait, we have to discuss two energies: the energy of the reactants, the energy of the product. Okay, let me tell you one more thing. The energy of the product will be less here now, so energy of the product will be there at the downside in exothermic diagram, and energy of the reactant is higher. Okay, so energy of the reactant will be here. Now see the diagram. Or you can change the color, or you can use dotted one. Okay, reactants. What are the reactants here? CH4 and O2. CH4 plus O2. What are the product here? Carbon dioxide and water. Why I am making products here? Because they have less energy. See, they have less energy. You can read the graph. And you can read the graph for the reactant also. The reactant have higher energy. This is energy level diagram. Okay, so this portion is the reactant. This portion is the product. What is this portion? Okay, see again. This point is the energy of the reactant. This point is the energy of the product or enthalpy of the product. So what is the central point? What is the central region? The energy change. This is the change in energy. Means, let me change the color. Yes, these were the reactant with higher energy, with higher enthalpy, you can say. They had higher energy. And then their internal energy releases and you got the product here. So the products are less energetic. This portion is change in energy, means this much energy have been lost. This much energy have been released. This is the diagram of exothermic. Most of the students are drawing this diagram the other way around because they are confused about this stuff. So basically, this is exothermic diagram. The students usually draw this diagram like this now. That there we have product, here we have reactants. Why they are making products here? Because the products are releasing energy or something like that. Energy level diagram means, energy level diagram is based on the energy of reactants and the product, the internal energy of the reactant and the product, not that energy which you are giving or which the reactants are absorbing from the surrounding to break the bond. Energy level diagrams are based on the internal energy of the reactants and the product. So definitely, if the reaction is exothermic, so reactants are having higher energy and the products are having less energy. So definitely, reactant will be there at higher level, and the product will be there at lower level. And this portion, this much energy has been released. You don't have to write the numeric values on the graph. This is not the graph. This is just energy level diagram, and this is the diagram which is based on internal energy of the reactants and the product. So the reaction is exothermic. So reactants are having higher energy because the products are releasing their internal energy to the environment. That's why the reaction is exothermic. Which reactions could be exothermic? Um, Combustion reaction. All the combustion reactions are endothermic. 90% neutralization reactions are exothermic. Uh, Whenever you react a metal with acid, the reaction will be exothermic. Mm, all the burning reaction or burning reactions are the combustion reactions. In combustion reaction, you can say the combustion of fuel, or the combustion of hydrocarbon, or the combustion of organic compound. These reactions are exothermic. One more. Oxidation of carbohydrate. Oxidation of carbohydrate means if you have any carbohydrate and you are adding the oxygen, the reaction is exothermic. Respiration, exothermic. There is one more reaction which will be exothermic, and that is most common in your past paper. Yes, the reaction of water with quick lime. We have slake lime, um, we have different lime water. Lime is stone, lime water is CaOH, limestone is CaCO3, calcium carbonate. What is quick lime? Calcium oxide. So the reaction of water with calcium oxide means if you react water with the calcium oxide, the reaction will be exothermic. This is most common exothermic reaction in your past paper. You have to learn this one. So these are the example of exothermic reaction. Let me check if I'm missing anything in exothermic. No. Yes, this is all about exothermic reaction. Is there any confusion? Then I'll move to endothermic. Yes, Sabur, any confusion here? In energy level diagram.
No, Miss, it's easy.
Okay. Yes, if any confusion?
No, miss.
Okay. Erina, do you have any confusion?
No.
Okay, let's move to another endothermic. What is endothermic? Endothermic, the energy will be now endothermic will be easy for you because you have done with the exothermic, so the endothermic is very easy for you. What is endothermic reaction? Let's discuss what are endothermic reactions. Let's discuss the example of endothermic. Um, Photosynthesis, endothermic reaction. Because what is photosynthesis? You can say the energy, the light energy is being absorbed by the plants. So energy is being absorbed. Photosynthesis is endothermic reaction. It will give you, I mean, during the endothermic reaction, the energy will be absorbed by the surrounding because in exothermic reaction, the energy is being released by the product to the surrounding. While in endothermic, energy will be absorbed from the surrounding. Heat energy will be absorbed from the surrounding. The surrounding temperature will drop. Surrounding will be cool. Photosynthesis always give the cooling effect. So photosynthesis is endothermic. Other than this, cooking. You have to focus on exothermic reactions. We have only few endothermic reactions. The cooking is endothermic. 90% of students say that Miss Cooking is exothermic. Why? It is giving you heat energy. No, cooking is endothermic because you are giving heat energy and your food is absorbing heat energy. Then it will be cooked. So cooking is endothermic. That is another story that after being cooked, the food is giving you some heat energy. I mean, that is heat up, na? So that is giving you heat energy. That heat energy is again, that heat energy is less than the energy which is being absorbed in a starting position or at a starting point. So cooking is endothermic. Other than this, let me tell you for yes, you have to learn a few example of endothermic reaction. You know, thermal decomposition reactions are endothermic. Thermal decomposition reactions are endothermic. Cracking, cracking in organic chemistry. No? In organic chemistry, we have a reaction which is cracking. That is just like thermal decomposition. Endothermic. What is thermal decomposition? You are giving heat energy. You are giving heat energy to the reactants so that or definitely you would be having some compound at the reactant side. You are giving heat energy so that the compound could be break. So definitely the reactant is absorbing heat energy. A lot of heat energy will be absorbed when then the compound will break. So all the thermal decomposition reactions are endothermic, like all the combustion reactions, exothermic. All the decomposition, thermal decomposition, not electrical decomposition. Thermal decompositions are endothermic. Cracking, endothermic, because cracking is another name of thermal decomposition reaction. Photosynthesis, endothermic. Cooking, endothermic. Anything else? Yes, you have to learn one more thing here. Uh, when you dissolve ammonium salt in water. You can pick any ammonium salt, for example, NH4Cl. This is salt, solid. When you make any ammonium salt an aqueous, means when you dissolve any ammonium salt, let me tell you, not any ammonium salt, certain ammonium salt. I mean, there could be one or two ammonium salt which are not giving the same reaction, but again, most of the ammonium salt will be dissolved in water and they will absorb heat energy. So the reaction will be endothermic. When you dissolve ammonium salt into the water to make it aqueous, so ammonium salt absorb heat energy. So the reaction is endothermic. That's it. This is all about endothermic. You don't have to learn more reactions. Now, the energy level diagram, that will be very easy for you because you have done with the exothermic. So endothermic will be easy. No? Let's pick some thermal decomposition, CaCO3, the most common. This is calcium carbonate, limestone. And you are giving some heat energy. It will absorb a lot of heat energy, then it will be broken into calcium oxide and carbon dioxide. This is the most commonest reaction. This is endothermic. What does it mean? For example, if you are giving 100 joules of energy, it will return back only 70 joules of energy. Where are 30 joules? Absorbed. So the reaction, or you can say during this reaction, extra energy is being absorbed. Or you can say in this reaction, less energy is being released. A portion of energy, that energy which I am supplying, the energy which is being absorbed by the surrounding, a portion of that energy is being absorbed by the reaction, endothermic. And you can say that one, reactant minus product, 100 minus 70 will give you positive 30. Positive delta H is positive. This is energy chain. This is positive, means endothermic. What is energy level diagram? Here, the energy is being absorbed. Okay, means the products will be having more energy because they are absorbing energy. As compared to reactant, they are having more energy. So reactant will be having less energy now because the products are absorbing energy. They are more energetic. So the product will be their upside.